Hello, welcome to the ASP.NET Community Stand-Up. It's April already, can't believe it. Joined by the team to find out what's new in Orleans. So I'm very excited about that. Cool. Well, we have just a few community links today. I'll pop over to those and we'll get that done. I'll turn it over to you folks. Let me see, I'll put us over here. Community links, I just shared them in the thing, and there's also a banner, and they're also in the show description. They're everywhere. So let's go. First of all, the Bing team posted about using dynamic PGO, platform guided optimization, in .NET 8. And I love this when the team does this. So these are, large teams at Microsoft running .NET at scale. And when we, they love taking advantage of new features that save them money, save the team money, give them better perf, etc. So this is continuing in a series. They posted before on .NET 5 and .NET 7. So here they turned on PGO. They describe how that works, that it's able to continue to reject code. This gets to the part where it's over my head, so I'll probably say something wrong. Go ahead if you want to explain.
It's very cool, actually, the way it works. And I think that there was a small blog, or at least a shout out from Stephen Tobe's his .NET 8 performance blog post, which talks about some of the algorithms involved in this, such as this probabilistic counting algorithm that they use to try to work out which paths are hot or which methods are hot, and therefore which ones are good candidates for more heavy optimizations, or how to choose which paths should be optimized, for example.
Wow. Yeah, so apparently, you want the app to start up quickly. So the initial JIT is optimizes fast startup, and then over time you'll see what the hot code paths are, and then rejit those to optimize for performance.
Exactly. And things like determining which types are used at a given call site. You see method devirtualization or interface devirtualization. By doing that, you can avoid expensive interface dispatch by just doing a very, very quick type check, and then jumping directly to the actual concrete implementation of something. So it can actually be a huge win.
Wow. Okay. Thank you for explaining. So yeah, so the interesting thing they saw when they first turned it on was steady state performance obviously improved, but they actually it slowed things down because there were some things that were not JITted at all at the beginning, and it turns out it was because there was they had a large number. It says there are 300,000 methods before they hit the first query. So they turned on these magic settings, so apparently you can give it some things, when to delay before JITting and that sort of stuff. After doing that, then they saw these big drops in CPU usage. So very happy about that. Saves them a lot of, saves some performance, or saves some both compute cost, but also saves, improves performance. So yeah, very cool. Okay, another thing here. So .NET 8 is an LTS. .NET 7 is STS, standard term support. So .NET 8 support ends May 14. So this is a reminder. This has been posted, for a while. This is this is posted on the .NET support policy. So this is the team, reminding about it, but then also did some work to link to. So we actually spent a decent amount of time on this post. Rich Lander rewrote some and improved some of the docs on upgrading your apps from .NET 7 to .NET 8, etc. So here's guidance on doing that. All right. Michaela, a cool post here on a new MS Build editing experience. So this is an experimental MS Build editor to understand the IntelliSense, do all the stuff for MS Build, including also giving warnings or links to documentation, etc. So I'm always little bit scared of working with MS Build, of breaking things. It's mysterious XML with all sorts of weird settings in there. So I'm happy from editor support I can get. So you mentioned Stephen Tobe earlier. Here's a very cool video. This is Scott Hanselman and Stephen did a looks like a first in a series, and they were implementing async await from scratch. So Stephen went through and wrote up in a little over an hour, wrote up the state machine, and he said it's about 90% of what async await actually generates for you as far as the state machine. All right, just a few more things here. We've got a few events coming up. So we've got VS Code Day coming up. This is really cool. Of course, we spend a lot of our time in editors. I use VS Code for a lot of tasks with .NET, including, the in-browser editor support from GitHub, and just a lot of, quick edits, and of course, cross-platform, etc. So this is a great way to just learn more about VS Code features, and of course, with C# support continuing to improve there too, it's great to know all the tricks and tips there. So this is coming up on April 26th. Another event is this Azure Developers .NET Day. So this is kind of flipping things around. A lot of our events are more .NET focused, and then we'll say, hey, you could do this on Azure. This is kind of for Azure developers, here's how to use .NET. So a lot of great things. Last year's event was really cool. And so this is coming up. This is April 30th, and it'll be exciting to see the stuff there. Learn how to leverage Azure services from .NET. Of course, there's neat stuff with Aspire, et cetera, et cetera. All right, my last thing here, I didn't know we can add any other Orleans links. This is a list of the recent releases. I was noticing in here we've got like Aspire support, all kinds of great stuff. I will stop sharing at this point, and I'll turn it over to you folks. So, and I'll pop us back on screen. All right.
Thanks, John. So my name is Mike Kistler. I'm a product manager for Orleans on the ASP.NET platform team. I'm relatively new to the job, but really excited about all the things that Orleans has to offer for folks, and some of the new stuff that we're going to talk about today. Let me try and get my screen share going. So share my screen.
While you're doing that, we had a question. I may have been saying, Ruben, how do you pronounce?
I pronounce it Orleans, but there's no definitive way. So Ben on the team, he often pronounces it the more French way, Orléans.
Yeah.
So it really just depends where you're from.
I'm always scared to try and pronounce things with any sort of French accent. It's never gone well for me.
Me neither.
Oh my gosh. I need to quit and reopen. Let me come right back.
Okay. All right. So Ruben, we were chatting beforehand. You are in Redmond, and this is the time of year where it's very beautiful outside, right?
Yep, finally perfect for probably, hopefully the next 3 months, fingers crossed. And then it's back to the typical Seattle rain.
Yeah. Cool. So, and then, so I think once Mike gets back on, he's got some slides to share kind of product, and then you've got a demo to show us after that.
Yep.
Okay. Cool.
Yep, we'll show off a few of the new features. Maybe we'll talk about some of what's coming, and then we'll demo Orleans and Aspire support.
Okay. Very cool. This is a great tip here. That's a good way to pronounce it. And then also, just while we're waiting, so do you work mostly, what sort of things do you work on the team?
It's a split between Orleans and more recently Aspire. Because we're trying to get Aspire out the door, I've been spending a lot of time on Aspire recently. But they go very well together. You could say they're designed to work well together. And so they're really complementary. In fact, you'll see that in the demo, that Aspire basically helps you with the things that Orleans doesn't do for you. So it'll help you to set up the application and everything. And it's really good for when you want to just get started with something. So when you're first building an application, you don't want to mess around with things like storage accounts and managed identities and plumbing through configuration and things like that. And the Orleans Aspire support essentially lets Aspire handle all of that provisioning and things and configuration. And then in the Orleans application, you'll see that you've just got your application code essentially. You can add Orleans now with just a one-liner. It's just builder.useOrleans. You're set up with storage providers and clustering and everything that flows through from the Aspire application host. So the experience is very good. I mean, I say that with bias, obviously, because I work with both things, but I'm really pleased with it.
I've been noticing with Aspire just what you're saying, that a lot of things are not really hard to do, but it's just enough friction that I'll think, oh, I would like to use Postgres, but I've got to install it and I've got to do this, or I've got, and then how do I set up the admin and stuff? Or I could just a few lines go add Postgres, add PG admin, boom, it works,
Exactly. So those things which were formerly paper cuts now go away, and some people would say it's too easy to make services now. And so some people are worrying that, oh no, people are going to make too many services and that's going to be a disaster. But the way we see it is we'd rather easy to make services, and then you can use your discretion to decide how big and small they should be. This way, as long as if it's easier to add a database per microservice, a Postgres server, then you're more likely to do that, which of course is good practice for encapsulation. So,
oh yeah,
welcome back, Mike.
Yep.
Yeah, thanks. Sorry it took me so long to get back. I don't know what was going on there, but anyway, I think I made it.
All right.
Just I'm asked to share my screen.
Okay.
There we go. Okay, and now let me start the slideshow. All right. So what's new in Orleans? So before we start talking about what's new, I think it's probably important to say, what is Orleans for people who might not know or might have, just passing familiarity with it. So Orleans is a cross-platform framework for building distributed applications in .NET that are robust and scalable. And with Orleans, we talk about this thing called the actor model, and actually specifically virtual actors, and that puts some people off. And so what I want to explain is that what we really mean here is that this is a simplified programming model for high scalability and fault tolerance. And when I say simplified programming model, that means that all of the user code that you write is single-threaded and it's shared nothing. And that's important because that makes it very easy to reason about. You don't have to worry about concurrency, things interacting in a bad way. You don't have to worry about race conditions and things like that, because everything is owned by that particular thread. Orleans takes care of the hard part. It manages the working set. It keeps only the hot paths and data in memory. And it manages the distribution of code and data across your distributed application, across all the various instances that are running. And I'll get into some of the terminology here in a minute. It also manages the routing of method calls either locally, if you're calling something that's on the same instance, or through the network. And this is used by many large-scale Microsoft services. So this is sort of the image of what an Orleans system looks like. At the outer layer, there's what we call a cluster. A cluster is a set of instances that are hosting your application. Those instances are something we call silos. Each silo can contain grains, and the grains are the actual business logic of your application. They can live in any silo, but only in one silo at a time. Okay, so there's only one instance of a grain at a time, and they're distributed across these silos in your cluster. So grains are inherently distributed. They're inherently asynchronous, and they're asynchronous because, as I said before, these can live on any of those silos, and Orleans completely manages that. So you don't need to know where they live, but you do need to call them asynchronously in case that has to be a remote method call over to another silo to get that work done. And these grains are also inherently single-threaded, as we discussed. Each grain has a well-defined identity or key so that you can address a grain and say, I want this grain to do something for me, right? And grains generally have state, and that state is often persisted to a state store so that it's resilient, so that if a silo goes down, then all of the state of the grains in that silo is preserved in the persisted store and can be read back in when the grain is reactivated on another silo. That persistence capability is injected into grains with dependency injection. And there are standard implementations for this for a lot of the common storage providers, things like Azure Storage, Cosmos DB, DynamoDB, etc. And this state is only exposed through rel-defined grain methods. So it's, as I said before, shared nothing. Users can access it only as the grain will give it out, and you don't have to worry about race conditions. There's a link here at the bottom to a talk that Ruben gave some time back, but it's a great introduction to Orleans, much more detailed than what I could go through here, that really explains some of the motivations for the design of the whole system. There are a bunch of advanced topics about Orleans that we won't go into here, but there's lots of documentation on the Learn site that explain streams and transactions, observability, heterogeneous silos. These would be silos where some grains need to live because of the particular capabilities of that silo. Grain versioning, what do you do when you need to update a grain and know its version? There's an Orleans dashboard that lets you visualize what's happening in your Orleans application. And Orleans is also available in F#, and we have some samples for that in the repo. Now, what's new in Orleans? The last time we did one of these things was when we put out Orleans 7.0. So since then, we've had a couple of features that have come out in 7.2. One of them is live migration of grains. And this allows a grain to be migrated to a different silo without having to be deactivated. That just means that it's a much quicker transition, and it allows better balancing of grains across the set of silos in your cluster. There's also support for IAsyncEnumerable being returned from a grain. And this is particularly handy. IAsyncEnumerable is a very nice feature in C#, and we wanted to be able to make that available to users of Orleans as well. So I'll describe that here in a minute. And then starting in .NET 8 Preview 1, we have two new features. One is resource optimized placement strategy. And this is a new placement strategy that complements some of the existing ones. And this one specifically attempts to optimize grain placement to balance resource usage across your cluster. And finally, there's Orleans support in Aspire. That allows you to have an Aspire application and have Orleans part of that Aspire application as a first-class resource that Aspire knows about, can provision, can hook into all of the other resources of the Aspire application. So real quickly on live migration of grains. When you have a grain, it used to be that a grain was either active or deactive or persisting or not persisting. With live migration, there's actually a few additional states. So I've shown the life cycle here, where you start by rehydrating state, and this is the state that's being migrated from the other instance. And then you activate, then your grain is running. And then when it's going to go migrate again, it goes into deactivation, dehydrates, and disposes. The way that you do this is there's an interface called iGrain Migration Participant. And this is an interface that the components of the grain need to implement. There's on dehydrate, which is called when you are about to migrate a grain. That's in the first part there. And that will take that grain's in-memory context and serialize it in a way that it can be re-serialized later on the on rehydrate when it's brought up on the new silo. You can trigger a migration of a grain with the migrate on idle method on a grain. And you can even choose which silo to send it to. Now, by default, it will go to the silo that the placement provider for that grain chooses, but you can influence that with a special method. I don't have the details here, but you can do that. All right, sorry, I can't see the chat. How are we doing?
Yeah, good. No specific questions here, so.
Okay, all right. I'll just keep going then. Yeah. The next up is the IAsyncEnumerable support. And again, this allows a grain method to return an IAsyncEnumerable of a type. So for example, here we have a get updates method that returns an IAsyncEnumerable of string. And basically this allows the caller to use this as a regular async enumerable, which would be done like this. You do an await for each, and then you'd get each of those updates and you do something with them. And that would happen asynchronously. The internal details of this is that what the caller actually receives is a proxy object that's called an async enumerator proxy. And that proxy object makes calls back to the remote grain to get the next value. That protocol also allows those results to be batched so that you don't have to go for each result. You can batch them up. It's not that you can batch them up. Orleans will batch them up for you and then hand them out without having to communicate on every one. You can set the size of that batch. That's configurable. And there's also a mechanism to switch to long polling if the next value isn't immediately available so that you don't have this long-lived connection over to the silo.
Yeah, it'll do that for you automatically, which is nice. So as a consumer, you just have to await for each with the grain method. And behind the scenes, Orleans will manage things like automatic batching and long polling, etc.
Yep. All right. So those were the two features that are available today. They were released in 7.2 initially. And of course, they were carried forward to .NET 8, Orleans 8.0. In the preview, we now have a new feature called Resource Optimized Placement Strategy. And as I said, this is a new placement strategy. It goes alongside the other placement strategies that are already there, which were random, local, hash-based, activation count, stateless worker, and silo role. So there's lots of information that's available at that link that I put there that you can learn all about grain placement. The new placement strategy, this resource optimized placement strategy, is based on monitoring a set of statistics on each silo, the CPU usage, the memory usage, memory available, maximum memory available, and then it tries to direct new activations for grains to the silo that is least loaded based on a score that's computed from these. There's a way that you can influence the weighting that's used on these statistics, and then to actually activate this, you just use the resource optimized placement attribute on your grain class to indicate that it should use this new placement strategy.
Okay.
And finally, .NET Aspire. So I'll tell you about the Orleans support in a minute, but for those of you that don't know, .NET Aspire is a new feature in .NET. It's a stack for building resilient, observable, and configurable cloud-native applications with .NET. It takes this curated set of components and builds them into an application that has built-in telemetry and resilience, configuration, health checks. And it makes it easy to discover and acquire these essential dependencies for cloud-native applications. And so Orleans obviously is a key feature that people writing distributed applications would want to use. So we added support for Orleans into Aspire. Starting in Aspire Preview 3, you add it by using the add Orleans extension method on the builder. And you say, I want to add Orleans. You give it a name, you say my app. And then you can configure the grain storage using the nice Aspire mechanisms for linking the different resources of your application together. You say, I'm going to have my Orleans grain storage be grain storage that I've defined and with clustering that I've defined. And then when you have a project, you can just pass that Orleans instance into your projects so that it knows, okay, now I can access my Orleans instance through this resource. You can also add it into the client projects by passing it in the same way with the with reference extension method. All right, and I think now is where I turn it over to Ruben to give us a demo.
Yeah.
Yep. Okay. Hopefully it all works.
We've got a few questions here. If now's a good time too, I'll throw them in here.
Yeah, sure. Let's go through them all.
Can Orleans use Netherite as a storage provider on Azure?
Yeah, so that's a good question. So for context, for those who are not aware, Netherite is a storage engine that's designed for Azure durable functions. And it's built on top of something called Faster, which was an open source cache or database storage engine from Microsoft Research. And you might have heard of that recently because Faster is also the basis for Garnet, which is this nearly drop-in Redis replacement. It doesn't quite have all of the features of Redis yet, like Lua support, but that's what makes Garnet so incredibly fast, is this Faster engine that sits below it. And so Netherite and that Garnet share that as a base. So anyway, Netherite is designed specifically for Azure durable functions. It does not, Orleans does not use the same kind of storage model as Netherite. Now that being said, we have talked about adding a workflow feature in Orleans in upcoming versions. And the storage model for the workflow feature in Orleans is more similar to what is in Azure durable functions, because it does store things using a log structured format. So Netherite probably still wouldn't be applicable because it's designed for this specifically for that serverless kind of a hosting model. But something similar to that, and potentially even something based on Faster would be in the future, because it again is very fast and powerful as a storage engine. So we'll see.
Okay, a couple more real quick. Do we need an iGrain interface?
Yeah. So the iGrain is the base interface that you put on all grain interfaces. So it's how Orleans, specifically the code generator in Orleans, it's how it knows that this thing that we've got here, that's a grain interface. And therefore, we need to go and generate some code so that we can communicate with that. So you need the iGrain interface in order to say to Orleans, like, hey, generate code for each of these methods that I've got here, and just know that this thing is a grain. And so be on the lookout for that. Mike mentioned grain versioning earlier. iGrain is how you tell Orleans that there is a grain interface, and that's also how Orleans knows that this thing may or may not have a grain version, an interface version. So okay. One thing is you don't need the grain base class anymore. So since Orleans 7.0, you no longer need to decorate your grains with a base class that you inherit from. We still generally recommend that you do because it's just a little bit more convenient. You get some access to some inbuilt things. But there's no strict requirement for that anymore. So you still need the interface, but you no longer need the base class.
Okay. All right. Last question for you. When to use Orleans or Azure durable entities?
Yeah, good question. I think there's actually a little bit of a comparison online on the MS Learn page for durable functions / durable entities. So Orleans grains and durable entities sound similar from a distance, but they're actually very, very different. So for context, a grain in Orleans is like an object. So in a typical object-oriented fashion, it's an actor or an object. It's a thing which has behavior and state. And these grains can call into other grains, and they can have reminders, and they can do things. Whereas with durable entities, they cannot be as active as grains are. So they can't call into each other. You can't use them in a very, very open general way. And they probably suit better in general for use with durable functions. So if you're building an application where you want to have fast request response, perhaps large processing graphs, then Orleans is highly suitable for that kind of thing. Like Mike mentioned earlier, there are many teams in Microsoft using Orleans just for that kind of a thing, analytics or whatever it is. But if you want to do things like long-running workflows, that's something which Azure Durable Functions is designed from the get-go for. And durable entities is an extension to that. So it gives you something akin to an object, but one which you can access from durable functions. So I would put it that way. If you want to have all kinds of request response and other sorts of flows or stream processing, Orleans is your bet. If you want to do workflows, then durable functions is the option there.
Cool. Okay, I'll let you get on with your demo.
Great. Okay, now let's see if I can present, or if I'm also going to have the same kind of an issue. All right. Do the typical thing. Can you see?
Gotcha.
Can you see my screen?
Yep.
All right. I'm actually showing you the wrong screen. Let's just switch over to. Here is our Orleans voting application. So this is the demo I want to show you. So you may have seen the Orleans voting demo before, because I believe we showed we've showed this demo basically in a previous presentation. But what I've done here is I've enhanced it with Aspire, and that's really the crux of this demo. And so you've got, from a high level, you've got two important projects here. The application host, which is, you can probably barely see it, but there's this little purple triangle, which is the Aspire icon. And this is the project which is going to orchestrate all of our Aspire dependencies. We'll have a look a bit closer at this in a second. And then you've got the service, which is built on top of Orleans. And so this is your actual application code. So you've got essentially something akin to orchestration / configuration code in this app host. And then you've got application host code in this service. And then down here, an Aspire convention is to have something called a service defaults project. And that does things, you can have a look at it. It does things like it configures telemetry, it adds health checks, service discovery, resilience to your HTTP client, as well as service discovery. And there's a line in here which is going to say, make sure that you also look at Orleans. So if you clone the demo from the Aspire samples repository, you'll see that these two lines there are important. And essentially that's it. So it's cross-cutting concerns is the goal of the service defaults project. Okay, so back to this app host project. So what this does for you is it allows you to say, I've got an application, and this application, cloud application, consists of multiple parts, and there are also some infrastructure pieces, and here's how those things relate to each other. And so in an Aspire app host, you'll always have this distributed application builder, which is declaring that you've got this distributed application. And then to that builder, you'll start adding pieces of infrastructure and services and then configuring them together. And so in this one, we're adding a Redis database. And so this will be spun up when I run locally, it'll be spun up as a container. And we're also saying that we've got an Orleans cluster, an Orleans application. And this thing here doesn't actually spin up any infrastructure for you. But what it does is it configures in the Aspire application model. So it's this model of your application in terms of the services and the dependencies and how they relate, et cetera. It configures an Orleans cluster. So then you can pass this around and say that this Orleans voting service, this thing I pointed to here, is part of this Orleans cluster. And when you're part of the Orleans cluster, you get this Redis. You use Redis for clustering. Sorry, all these pop-ups are getting in the way. And then we're going to also configure some grain storage called votes, which is also using Redis. So we're basically here saying something pretty simple. We're saying, I want an Orleans cluster which uses Redis as a clustering provider and also uses that same Redis instance to store votes. And then so to our application, we say that we've got this voting front end, so that'll be its name. And in Aspire, we use code generation to generate this little token here that says that when you add a reference, let me show you. When you add a reference to a project, Aspire will generate some code which allows you to reference that project in a type-safe manner. So you can say that I want to add the Orleans voting service code. And there's a way you can give projects aliases by configuring an extra property here. So if you've got some project which has got an unspeakable name, then you can give it an alias, and then you can use that alias in code. And we also want to say that because this is a distributed application, we want to say that we've got 3 replicas of it. Mm. So we're going to spin up multiple different Orleans voting services when we hit run. And then we're going to tell them to all connect to each other. They're going to discover each other via this Redis clustering that we've added. And they're also going to store all of their grain state in this votes Redis storage here as well. And let's also have a look at how you actually add Orleans to your application. So I've got this typical voting service, which is just a clone of that Orleans voting demo. But in this demo, I've removed all of the config code, essentially. And I've replaced it with just this one-liner, builder.useOrleans. Now, what this does is in Orleans 8.1 previews, we've added support so that Orleans can read configuration from my configuration. And when we go back to the app host, this here is going to create a configuration blob, which says, hey, there's for clustering, go and have a look at this Redis clustering configuration. So when we call use Orleans here, Orleans is going to look at iConfiguration. It's going to look at the clustering section. It's going to see that we've got a Redis clustering provider that's named voting Redis. And then it's going to go to dependency injection, and using key DI, it's going to go and look up this voting Redis connection. So this here is the Aspire Redis component. And if we go and have a look into our package references, you can see that I've added the Aspire Stack Exchange Redis component. And that's what gives us this builder.addKeyed Redis client extension method. Then we call into the add service defaults project. This is just the method that we added here. Again, this comes automatically whenever you have an Aspire project. And then, like I said before, we call use Orleans. The rest of this is just setting up our Blazor application.
Okay.
Before I hit F5, are there any questions?
I don't think anything to interrupt you about yet. No.
All right, let's just see how it looks. Okay, so when you have an Aspire application, this thing is going to be responsible for essentially orchestrating this application. So what we expect to happen is when I hit F5 or click the run button up here, it's going to spin up a Redis container. It's going to spin up 3 instances of this service, and it's going to tell them which ports they should all listen on. It's going to give this thing the connection string to the Redis that I've configured. So let's have a look and see if it does that. This is where fingers are crossed. This stuff is all in preview, so. All right, debugging it. It's starting up. It's launched a dashboard, and so that's popping up on the screen now. And so what you see here is the Aspire dashboard. And you can see, yes, it's created our voting Redis container that's listening on this endpoint. And it's also spun up 3 instances of our Orleans voting service project. And so if I click on this endpoint here, it will take me to this grain poll, straw poll-like page where you can go and create polls, and you can then share them around and vote on them. But just for expedience, we've got this autofill poll button. So we click that. It asks, what is your favorite color? Which is an old Monty Python reference. And so then you can create this poll, and then it takes you to the voting page that you can share around. Of course, only if people can access your application. And then you can vote on something. And so now you see, it's a little bit too zoomed in, but now you see we've got one vote for blue, no yellow. But I can click this button to simulate other voters, and we'll see what happens is the page, which is a Blazor application, gets updated live based upon all of these.
You can click that. Sorry, but down at the bottom where it said you can click hide. Yeah.
Okay.
Cool.
Great. And so yeah, this is our voting application. It's pretty simple. The more interesting part is that we've done this and orchestrated it all together using Aspire. And so this dashboard it's not just here for looks. It does serve a functional purpose. Aside from being able to see that all of our things are running and what all of our resources are, we can go and have a look at logs. And if I click on the logs button next to one of these, I get the output. I've got some diagnostic logs from Orleans. And this is just console output, but I can still go and have a look at all of these different things. I can have a look at the Redis container as well. But because .NET supports iLogger with structured logging, we can also get structured logs. So in structured logs, it will parse out different aspects of the log so that these things are parameterized and it knows the log level and the times, etc. And if possible, it might also link you to a trace. So we can see the trace for when we're establishing a connection to this particular silo over here. And clicking this will take me to the traces page where I can see distributed tracing. And so we can see where it establishes a connection and then gets the silo manifest in this case. So that's some pretty internal stuff, but you can see all of it from here if you want to. So there's a membership ping, and you would probably see some votes if I scroll up enough. And so those distributed traces can be quite useful for diagnosing things, especially when something goes wrong. I don't think I've got distributed tracing here set up with Redis yet, by the way. So you're not seeing any of the calls to Redis. You can also go and see metrics for your application. So this uses the .NET metrics system. And because I told it to go and look for Orleans metrics, we can do things like see the histogram for request latency, or the directory ring range size, and all sorts of other things like how many grains. It's only one grain because it's just this voting grain. But we can see all of those kinds of things from the 3 different silos on there. So it is quite handy. In addition to that, you can have a look at the environment variables and the endpoints that get configured and passed to the application. So that's the gist of the demo, especially the Aspire part of it. Do we have any questions in chat?
Yeah, we do have a few questions. Let's go. Okay, so can Orleans be used in languages other than C# and F#?
Orleans is specific to .NET. So it's designed, part of the, let's go and have a look at some code to motivate a bit of this. So let's click stop here. If we have a look at some of these grains, these grain interfaces are designed so that Orleans knows to generate code specific to these types. And it will generate code which is specific to list or dictionary. And if you've got a dictionary comparer, it will propagate all of that with high fidelity from both sides. Now, the upside of that is, as a .NET developer, you get a very good experience because you can use the types in .NET and be sure that they're going to persist from one side of the wire to the other. Like your dictionaries are not going to be arbitrarily reordered, for example, if you've set a comparer on them. Things like that. And you don't have to do a lot of marshalling to and from these low-level wire types to application types. Mm-hmm. Now, the downside of that is that you can't, you basically can't represent these kinds of things like generics in some languages. Like a lot of languages don't support generics. If you want to be able to support things like generic grains, so you can have parameters on your grains, or generic methods, or polymorphism, or be able to represent graphs, those are things which are only available on some type systems. And so you can't do this kind of thing in other languages. And so for that reason, Orleans is really specialized to take advantage of as much of .NET as it can.
Okay.
I mean, without going overboard, but it wants to give you a good high fidelity representation of that.
Okay, makes sense. Spire question here: where are Spire logs stored and configured?
That's a good question. So when I run locally, those logs are kept in memory in a circular buffer. So the dashboard will have a certain buffer for logs and metrics and traces. And once that buffer runs out, it'll start replacing again at the beginning. So actually, it's funny, in the .NET Conf presentation we gave for Orleans 7, we had to make sure that we launched Jaeger just before we started the demo, because Jaeger would pretty quickly run out of memory and crash if we were to keep it running for too long. It's not really meant for demos, but the Aspire dashboard is designed mostly for local development. I mean, that's definitely where it starts. And so a lot of it is about that developer in a loop. And so it doesn't persist them. Now, that being said, all of the things that Aspire configures, in fact, we can have a look at the service defaults project. All of the things which Aspire configures, it configures in a standard way. So it doesn't have a proprietary protocol for going and fetching logs or metrics or traces from your application. It actually uses the Open Telemetry protocol. And so in doing that, the one nice benefit is it works with Node.js apps and it works with Python apps, and you can configure telemetry and those things as well. And so you can have a polyglot application, which is pretty common in microservices. You might have a Node front end with a .NET backend, for example. And because it uses OTLP, well, Node, NPM, Node and Python can support OTLP. And also in production, you can configure that to point to a production grade OTLP endpoint, which does persist your logs and allows you to search them for a long period of time, rather than the default experience, which is just to have a circular buffer in memory.
Okay. All right. Well, we're a little short on time, so I've got 2 more questions. I'll throw them at you if we can hopefully go through them kind of quick. There's a discussion going on in chat about whether you can, since Aspire is in preview now, are you, some people are saying you can't use it legally yet. There's no go live. I mean, it's in preview. Is there? But my understanding is you can use it, but there's no support for it yet, or it's not.
I don't know how much has been announced publicly yet about when Aspire is going to go live, etc. But it's happening this year.
Yeah.
And it will be supported once it does, and you can expect regular updates to it and regular enhancements to it as well. So it's great. At least, I mean, even without going live, Aspire is great for your inner loop. And it's not going to negatively impact your production experience anyway. So even if you're not using it for your production applications, let's say because you're already using Terraform or you've already fallen in love with YAML templates or something like that, you can still use it for the dev inner loop experience. And when new developers join your team, they can clone the repo, hit F5, and get a debugging experience. One thing I didn't mention about Aspire is that when you hit F5 I use hit F5 as a shortcut for launch your application.
Yeah.
Hit F5. When you launch your application, Aspire will debug all of the app instances. So if there's an exception in one instance of your service, you don't have to manually say, hey, debugger attached to this instance of my application. It will just break. If you've got a breakpoint there, the breakpoint will get triggered. I believe at some point we'll probably have Playwright support. So if you want to write integration tests against your Aspire application, and orchestrate those, browser-based integration tests using Playwright, you'll be able to do that. And if there's an exception, you'll see that exception. And similarly, I believe in Preview 5, the next preview of Aspire, something which has been sort of near and dear to my heart is support for integration testing in general. So if you want to be able to orchestrate your application and perform an end-to-end test, let's say that you've got a front end and Orleans middle tier or whatever it is and some back end, and you want to perform a real integration test, you can use the distributed application test builder. And what that will do is during in XUnit or whatever it is, it will go and run all of your dependencies and give you a HTTP client which points to, say, the front end, for example. And so you can run tests on the front end, which then flow all the way through to the back end. And hopefully soon for that, we'll also be able to give you logs and and traces and all of the other kinds of things which Aspire collects. But again, if you're debugging a test and something fails in one of the dependencies, it'll break in Visual Studio and you'll be able to see what's the cause of the exception, etc. And so the debugging experience is much, much nicer than what most people get today without a lot of setup. Which is, I think, part of the beauty of it.
I've loved that as a developer tool, not having to start this project, start that. Oh no, I didn't start this in debug. Oh no, what's, you know.
Yeah, exactly. And as a lot of people start developing AI applications, you know, most, if not all AI applications are inherently distributed, because you've got some model running in a container somewhere, or you've got a model that's in OpenAI or Azure OpenAI or wherever your model is running. And then you've got an application which calls into that thing. And so using Aspire, you can orchestrate all of that stuff together. It can go and provision bits of infrastructure in Azure for you, and then it'll flow the connection information through. And if you know, managed identities can be configured and everything like that. You never have to touch a connection string. No secrets in user code. Which again, a lot of these are not. I mean, I would say they're not groundbreaking in that it's not like, wow, you know, no connection strings. But these are all these paper cuts which really hurt you when you're trying to develop an application. And Aspire has a principled way of dealing with all of those things. And that's why it works so well with Orleans. You know, all Orleans applications are inherently distributed, and they all tend to need something for, say, cluster information and storage, because any real application has to have some kind of storage. And Aspire just makes that, like you saw in the demo, it's like 2 or 3 lines of code, you know, one in your application and a couple in your app host, and it'll orchestrate it all for you.
It's such a natural fit. Yeah. One more question here, and we are getting close to our time here. So after this, I'll ask for any kind of like next steps and roadmap or any other things.
Right.
So last question here, can you handle distributed transactions in Orleans or modify with a custom implementation?
Yeah, so in Mike's slides, he mentions one of the advanced features of Orleans is transactions. And so we do have distributed transactions in Orleans. They can be a little bit more rough around the edges as far as the user interface is concerned. We've got a sample application which shows you how to do that. And so it implements distributed transactions on top of whatever storage you're using. So you might have blob storage, for example, for your grain state, and Orleans will manage transactions on top of that, you know, otherwise non-transactional storage. So yeah, you can most definitely have distributed transactions in Orleans.
Okay, cool. All right, well, this is great. As far as kind of next steps or keeping up with things, there's I can share a link for the docs. Is there any kind of roadmap or looking forward things? I mean, I'm assuming Aspire is kind of big stuff.
Yeah, so I think I would say, first of all, you know, we wanted to make sure people knew about the features that we've already released in GA. You know, please go out there and use them. Give us feedback on those. But even more, we want folks to know about the preview features. We want feedback on those. The preview is the time really for you to influence what we do when we release as GA. And so please give those things a try. Let us know if they're hitting the mark or if there are any rough spots, so that we can take care of them before we hit GA. And I think there are some more things coming in .NET 9 that we haven't been able to talk about yet, but you know, watch this space. Hopefully more to talk about before we actually ship .NET 9 for
awesome.
Orleans.
Okay. Here, let me share. Also, Ruben gave me a link to the Discord, so I'll share that in the comments as well. And then I'm going to be a good citizen and end on time so that the VS Toolbox folks can get on. So thank you so much. Great demo, great information. Awesome to hear about what's new. And yeah, this just is such a natural fit, such a useful thing to be able to use Aspire and Orleans together. So this is great.
Thanks, John.
Thanks for having us.
Okay.
Thanks, everyone.
Thanks, folks. All right.